Hello and welcome to Identirati Office Hours. I'm your host, Mike Schwartz, founder of Glue. And this week, we're going to talk about some new things in OAuth, including first party mobile authentication and global token revocation. And I have as a guest Aaron Parecki. Welcome, Aaron.
Hello, thanks for having me.
And we're just going to dive right into it. Actually, on this episode, I wanted to talk about first party mobile authentication. Aaron wanted to talk about global token revocation. So we split the difference. We're going to talk about both. And we're going to start with first party mobile authentication. And Aaron, maybe you can tell, like, why was this new flow needed? What was the demand that drove this spec?
Yeah, so with the first party apps spec, I hear again and again from developers that people don't like the user experience of logging into a on a mobile app specifically, logging in using the browser that slides up um, inside of the app, which is the correct API to use for third-party authentication. And in a first-party context, it's a little bit weird, and people work around it in very creative ways to try to avoid that experience. So everything from just using a password dialog in the app to if they're actually using an OAuth server for their own first-party apps, they have done very creative things to kind of hide it from appearing to be a website. So it's really about acknowledging the fact that this is a problem. People don't like the way it looks and the way it works from an end user perspective, and acknowledging that and trying to come up with a solution that's actually going to be better.
And I have to plead guilty to this one a little bit because here at Glue, we hack the password credential grant and we add in like a state and we end up implementing multi-step password credential grant flows. And that was our workaround. Do you see other people doing things like that, or are we the only guilty ones?
No, no, definitely. Lots of people do that. And you kind of pointed out the other problem with it, which is that if you're trying to do authentication with anything besides passwords, there's no path to do that well. So you're kind of just making stuff up. Like if you wanted to do MFA or do any kind of other types of credentials or passwordless, just email magic link, that kind of thing. Like there's no pattern for it in the OAuth world because all you have is a password grant, which you can kind of cobble things together on top of. The I've seen people build other versions of that kind of proprietary API, or even doing things like putting the web view on the screen but hiding it, making it invisible so people can't see it, and then kind of injecting code into it or injecting the user's password into it from a native form control. Just people have done very, very interesting things.
And what about, one of the things that I've heard personally is the browser's also doing some unexpected things, and developers just really don't want to use the browser because of the potential for weird browser pops they have no control over.
I think it just gets back to the again in a first party scenario when someone's building a native app that is just using their own login to their own server to get tokens for a backend service, you don't have a lot of the issues that arise that led mobile platforms to create the APIs that launch the browser in the first place. So things like you're not going to put your Google password into some third-party application on mobile
One would hope.
because hopefully not. But Google could ask for the Google password in a Google app, right? Now, interestingly, they actually don't. They're an example of they've actually gone full OAuth for all of their apps. And if you ever like download the Gmail app and log into it, you actually do get that web browser experience. And they've just decided that the benefits of sticking with the OAuth redirect model, even in mobile, are worth it. But not everybody has come to that same conclusion.
Yeah, let me actually try and share what this spec defines. So I have a screenshot here of the first party. Here it is. Hopefully that this is the right one. This is our
Yeah.
beautiful diagram. And so maybe you could just walk us through this. Like, what I liked about this spec personally was that it seemed like a code flow that happens on the back channel. But maybe you can just walk us through
Yeah,
quickly
well,
what the
let's
spec does.
jump right in. So the before we get to the sequence diagram, at a high level, the goal here was to create a analogous version of what happens on the web, but being able to use it in mobile. So if you think about the way that OAuth works on the web, uh, the client starts by building this URL and redirecting the user to in their browser to that URL, which is the authorization endpoint. At that point, OAuth doesn't say anything about what happens, right? And the user authenticates somehow to the authorization server. And that could be any number of different things happening depending on the product. It could be just a password login. It could be password plus multi-factor auth. It could be passkeys. It could be email magic link. It could be social login, right? It doesn't really matter. That part's left out of the OAuth protocol because the OAuth core protocol is just talking about how the client talks to the authorization server. At the end of the user authenticating, the authorization server creates an authorization code that represents the fact that this user has logged in and agreed to whatever the prompt was, and sends that authorization code back to the app, which it can then use to exchange it for tokens. So we wanted to take that same concept and apply it to mobile, where the client would start the request, do some back and forth with the authorization server to get the user authenticated and agreeing to whatever. But the output of that is still an authorization code, which the mobile app can then turn around and go back to the token endpoint and exchange it for tokens. The nice thing about doing it that way is you don't need to change your token endpoint at all to support this. The token endpoint still accepts an authorization code. That also means everything that is built on top of the token endpoint can still be used, including doing things like binding the access token to a public key on the phone for using Depop or whatever you want. So really what this is doing is this is creating this new endpoint called the authorization challenge endpoint, which handles just the mobile specific parts of getting the user authenticated. So client starts, we can go step through this diagram now. The
Sure.
client starts at the authorization challenge endpoint by making this request, which can have no information in it, or it could have an email address that the user has already entered. It could
So this
have
is a new endpoint, right?
new endpoint, authorization challenge endpoint, and this is a post request that the client makes directly to the OAuth server to this endpoint, and then it'll get back either a error saying it could be an error that says like we're totally stuck, or it could be an error saying I need more information about the user or from the user, like a second factor of some sort, or it would be an authorization code. So that's so A, B, C, and D in this diagram are the sort of that's the back and forth. The authorization code is issued in step E, and at that point, F and G are not changed from regular OAuth. That's just a
Right.
regular token endpoint.
Right. And in this process, though, you've introduced a new, I forget the exact parameter name, but like device session, in case there's a multi-step interchange when you're
Yep,
doing the authorization challenge. Is that correct?
exactly. So the I think we renamed it from device session, so it's called I think it's called I forget what it's called now. Oh my gosh, let me find it. Um, it is called the auth session. So the idea is it is meant to live from the first part of this flow until the authorization code is issued. So it's meant
Hmm.
to be a way to link the back and forth requests that are going to happen throughout an exchange.
Sure. It's your pre-authentication state, basically.
Yeah, yeah.
Um, okay. And I think, let me stop sharing. So, I mean, it's pretty simple, actually. If you're familiar with the code flow, like I said, it's basically a code flow that happens on the back channel. And you get authenticated in n number of steps. You get back this code, and then nothing changes at the token endpoint. You present code plus client credentials. You get back tokens. Now, do you get back an ID token?
Well, it's this is defined in the OAuth layer. So that's this
Right.
draft is defined at the OAuth layer, which means um, actually, this draft doesn't care. So this draft is saying this is how an app can get an authorization code, right?
Yeah.
It doesn't say it doesn't make any requirements about what that means. So if you add OpenID Connect on top of it, yes, the app could get back an ID token, assuming that the app has included the OpenID scope in the first request.
I don't really see that ever happening because I think of the OpenID layer happening in the browser, and I don't know, but
There's
if
no,
you
there's no, no, there's absolutely no reason it wouldn't work. So the in fact, you don't even have to get an ID token in a redirect in OpenID. Like you can get an ID token from the token endpoint in
sure.
OpenID Connect. That's entirely possible. So if you have a you can do the authorization code flow with OpenID Connect, get the authorization code, and then your server can go and request the ID token from the token endpoint in OpenID Connect. So same thing would be possible here as well.
And it makes sense because you do have an authentication event, right? The person got authenticated in a multi-step process, so it has all the same attributes of an authentication event that happened on the web. So an ID token would be appropriate, although really you could just return
Yep.
an access token too if you wanted to.
I
And
mean, there's reasons to do both, right? There's the access token is meant to be used to access data. So if the app is going to go and hit APIs, it's going to use the access token for that. If the app needs to know what the user's name is, that information is in the ID token, right?
so I'm going to pull up this diagram that is a little bit too small, but we'll just sort of use it as a point of reference. And I just wanted to maybe sort of highlight that this authentication of the person happens as part of a bigger process. And OAuth defines a number of these steps from how the client registers to how it obtains access tokens to what kind of access tokens these are. And OAuth isn't just one thing, it's really a bunch of things. And those things are evolving as we speak, it seems. Um, but what I find interesting is that potentially the client could register, so we can obtain a chain of custody, basically from the app being published to the app instance registering to the person then perhaps enrolling FIDO credentials and then undergoing this first party authentication that you've written, getting a Depop access token that's sender constrained, and then sending that off to an API. Um,
Yep.
so in a way, you might say, well, this is a really lightweight protocol, this authorization challenge. Maybe it's not as quote unquote good as OpenID Connect, but you put it in the context of this larger sequence, and you could get a pretty darn good, level of assurance that this person is actually authenticated by using this spec.
The I mean that was really the design goal, is that this is it's a small piece of the puzzle. So there's a lot of other things that would go around it, but it's meant to just slot in right there of like this is the standard way that an app can talk to a server to get the user authenticated. If you didn't have this spec, the app has to do something, right? And that something is either people make it up on their own and then do it in unique ways individually per authorization server, or they could do the web version. And in the web version, that back and forth is still happening. It's just happening in a browser instead, right? And that was kind of the key thing that led me to do the spec this way, which is that in OpenID Connect and in OAuth, in a web flow, in the authorization code flow, this back and forth is still happening. It's just happening in a browser with HTML and JavaScript served by the authorization server, rather than natively interacting with the client. So there's any number of things happen in that browser when you're logging into the authorization server, doing any number of sequences of email challenges or identity proofing things, like to get the user to be logged in. So that already happens on the web version. We just need a way to do that on the mobile version.
And what's the current state of this? I was looking at a 0.0 draft. It sounds like there's a 0.1 draft that you have in your on your laptop. And what's
Yeah, it's early stages. So this is just to be very clear, this is not yet adopted by the working group. So this is a what that means is that this is an individual draft. We are on actually the third version of the draft. We renamed it at one point, so there's two zero zeros and now there's a 0.1. Published 2 months ago. Individual draft at the ITF means that it is some random person's idea that they think is interesting and has done some work to create a draft, but nobody necessarily agrees with it yet. So the next step here is, so I have presented it to the OAuth group a number of times now for the last couple of meetings, and at the next meeting in July, um, the next stage of this would be to get the group to adopt it. That would be the next step of the process. And if the working group adopts it, that means that enough people in the working group agree that there is a problem and that this is a potentially good solution to that problem.
and you're not the lone random person who maybe wants this. Is there some other?
Yeah.
I know I see George and I think Peter, but do you know anything about why they were interested in this topic, and maybe speak to some of the other members' interest or feedback so far?
Yeah. So far, the every time that I've talked about this in the OAuth group and elsewhere, including like the OAuth security workshop or other events, I have received a lot of positive feedback. People definitely agree this is a problem and would like to see a standardized solution. And again, I mentioned that people have come up with alternatives to doing the OAuth redirect flow in mobile because because they don't want to do that flow. And I think people are excited about having a standard way to do it that's actually properly in OAuth rather than just having to make something up. So I have gotten a lot of people coming up to me later and saying, "I'm so glad you're working on this. Like, we will absolutely use this." So that's really it's good feedback.
Yeah, and I can add my voice to that because we we actually, sometimes you read something and you're like, it's so darn simple. Why didn't I think of that? And
Right.
this one was one of those, and it just obviously such a good design. So yeah, I know there's always a lot of like the last mechanics about what that parameter should be called, and probably
Sure.
everyone's got
Yeah.
an opinion. But yeah, and in a best case though, let's say in the next meeting they adopt it, what would timing look like?
I mean, it's impossible to predict timing of any of these standards. Really, it's a combination of how complicated is the thing that you're doing, how many people are interested in it, but also interested in actually helping helping with the document. So, like the it can we've seen drafts go to RFC, which is the final stage, publication stage, anywhere from like a couple of months to like 7 years, right? So it just depends on, are you talking about a very complicated thing that is possibly
Right.
controversial, or is it a very straightforward thing that everyone agrees on?
Right,
So
that's a very good point. Yeah, I think
yeah.
Depop itself, has been out there for a number of years, the Depop access token standard.
Yeah, and one of the ones that went actually very smoothly was the ISS response parameter. I do not remember the RFC number off the top of my head, but this was identified as a problem if a client ever talks to multiple authorization servers. There's a possible mix-up attack opportunity in certain conditions. So this new parameter that the authorization server can return solves those attacks. And this one was extremely fast. Essentially, it was like, yes, everybody agrees this is a problem under these conditions. This is a single parameter being added to the flow, which solves the problem. Not very controversial, and then it got published. It was very quick. So
Who
it just
knows?
it just depends. It depends.
So, okay, let's switch. I think that covers mobile. Anything I missed on mobile, first-party mobile authentication?
Let me see. The yeah, so the just to reiterate, the one of the goals, design goals of it is to build on as much existing infrastructure as possible. So I would like someone to be able to add support for for this spec without having to like completely rebuild everything about how they issue tokens, right? And that was the reason for reusing the token endpoint, as opposed to having a new endpoint that returns tokens just for mobile apps.
Yeah.
Oh, one other thing is, so I do expect that authorization servers, different authorization server products will want to support different subsets of actual types of user authentication. Like some authorization servers might be happy to just do a password as the only factor. So that would actually look very, very simple. But in many cases they want to do multi-factor, or some authorization servers will have email magic link as a login option, others won't. So there's going to be a bunch of different combinations of what types of authentication mechanisms are actually implemented in this. However, there is one that I think will be very useful to everybody, which is passkeys. So I'm actually working with Tim Capelli on adding support for passkeys into this draft, either in the draft or as an extension of like, here is a standard way to do passkey login and registration for mobile apps using OAuth. Because again, you can do it today, obviously, but like it's not a standard yet. So
Tim Capelli of Okta, not of Microsoft,
yes,
right?
of Authn now, yeah.
Yeah. And Tim will actually be on the show, I think in June sometime, early
Oh,
June, if
great.
I'm not mistaken. Yeah. So we'll dive into that one in detail. It's a fascinating um, evolution of, because um, we're going to be able to do a strong binding of the person to the device, and then this device person combination cryptographically. It's going to make this first party mobile authentication spec really, really powerful, I think.
Yeah, yeah,
I'm super excited about that,
I'm
actually.
excited.
It's like, this is a question that's sort of been hanging out there for such a long time. And I think like we finally have an answer where we can go to mobile developers and face them and say, this is actually a good idea. You should do this. Um, so yeah, so great work, Aaron. And now let's switch to global token revocation. Um,
Sure.
Now, I didn't know anything about this spec until you mentioned it, so I'm glad you did.
Okay.
I went back and read it. The truth is that we have been really staring at token revocation hard at Glue,
Hmm.
because we have customer requirements for what we call transactional tokens, like single-use tokens. I present it, it gets used, and it's immediately revoked. Or that worst case hacker person, we want to revoke all of the person's tokens. And how do we do that in real time? So we've been looking at this hard. So it's very relevant to some of the struggles we've been having at Glue. Um, but maybe tell me what was Okta's interest, or what was your personal interest that drove the design of the spec?
Yeah, so the basic idea with the global token revocation spec is to provide a endpoint at an authorization server that can accept a request that will revoke all of the tokens for a particular user. So the main use case for this is things like user account compromise or device compromise. So that's the sort of easiest, simplest to understand answer problem. I lost my phone, lost my computer, and I'm logged into a bunch of stuff on that computer through my SSO identity provider. The identity provider should be able to tell all these different apps to go and revoke these tokens. So if I'm logged into Slack, then Slack should be able to revoke all the tokens for a particular user on demand from the identity provider. And if you look around at some of the existing applications that do this, there are these kinds of revocation endpoints at SaaS apps right now. There's a handful of them that have a revocation endpoint in their public API docs. I don't remember off the top of my head which ones I was looking at. I think Google and Zoom, and there were a couple others that I found very quickly found API docs on like, here's an endpoint that you can use to tell this
Yeah.
app to revoke all the users' tokens. So when there is this sort of emergent standard, that's potentially a good opportunity to create an actual standard around it, right? All these different companies had endpoints for this, and someone like an IDP like Okta can go and call those endpoints to revoke a user's tokens. But you have to write proprietary code, one-off implementations for each of those. Wouldn't it be nice if that was a standard? And anybody can just pop up this endpoint and accept revocation requests. So that was the kind of motivation for it, right? Of you want to be able to say to these apps, really just nuke everything, like get rid of all this user's tokens. They're going to log in again from scratch to get new tokens, and doing that in a standard way that anybody can quickly build on top of.
Now, I understand this especially applies to refresh tokens. But what about access tokens, especially if those access tokens are
Yeah.
JWTs?
I mean, that's the real challenge. So the the if you're building an authorization server and you got access tokens and refresh tokens that you're issuing out to users or out to applications, this spec is not ambiguous, and it says refresh tokens absolutely must be revoked. That's basically the entire point. And that's because if you didn't revoke the refresh token and someone's device was compromised, it can still keep getting tokens, right? So we want to make sure we get rid of the refresh token. Access tokens are a challenge because of some authorization servers issuing JWT access tokens, which that is a self-contained token that is signed, and it says how long it's good for, and it can't change by definition. Like the server creates the JWT, gives it to the client's holding on to it, the server doesn't have it anymore, so there's no way to revoke it. So it's a challenge. In many cases for authorization server implementers, it's a challenge to revoke JWT access tokens. It's not impossible. There are ways you can do it, but it is definitely more challenging compared to deleting something out of a database to revoke it, right? A couple of techniques you can use. You can do things like every access token can have a unique identifier in it. The JTI claim is used for that. And if you wanted to revoke a particular access token, you know how long the token's good for. It might be good for like an hour. So you can take that JTI value, put it into a list, and cache it for an hour so that you know that particular token is revoked. Getting your APIs to actually check that list is the next challenge. So depending on your architecture, again, figuring out how to do that can be a challenge. There's another option, which is actually a draft in the working group, a separate draft in the working group, about keeping status lists for these kind of revocation events, and doing so in a way that actually is scalable and can be distributed better. So there's it is, I believe it's called token status list, or
Right, you referenced it
OAuth
in one of
status
the
list.
documents. Yeah.
Yeah. This is a way for, essentially, it's a way for the authorization server to say this token belongs to this byte in this long status list, and then those status lists can get quickly distributed and cached. So it's another way to do it. Again, none of these are perfect compared to deleting something out of a database to do a revocation, but there's several techniques you can use.
It reminds me a little bit of the problem of revoking smart cards, because smart cards are also like pretty static, and so then you get certificate revocation lists. So I feel like we're optimizing this very similar problem.
It is, yeah. It's so as far as the global token revocation spec goes, it recommends that the authorization server should also expire access tokens, but it's not a requirement just because of the practicality of it. The real thing is that revoking refresh tokens is the requirement, because that's the whole point.
Right.
I should also mention it's always a good idea before you make something new to go do some research and find prior art and see what else is out there. So there are some other revocation specs that are out there that do sometimes similar things to this. So one would be the spec in the OAuth in the ITF called token revocation. Why can't we use that? Well, that spec actually, what that's for is for a client to tell the authorization server to revoke a particular token. And that means the input to that request is an access token. And what we're talking about is a problem that works the other way around. We're talking about an authorization server or identity provider, usually, or it could be a security monitoring tool, wanting to tell an authorization server revoke all tokens for a particular user, where the input to that is not an access token. It's not one of the tokens that's been compromised. It's just, hey, this user ID needs to get revoked, right? So that one doesn't work. There's also OpenID Connect front channel logout and OpenID Connect back channel logout. Front channel logout doesn't make any sense because again, that's client initiated, and it of course only works in the actual browser. That's where the front channel is. So again, we're trying to do something server to server. Back channel logout gets close to this. Backchannel logout is a server endpoint that the OpenID server has that can accept requests to log out a user. However, most of the language in the spec talks about terminating sessions for that user, not necessarily access tokens and refresh tokens that were issued. And it actually says that refresh tokens issued with the offline access scope should not be revoked, which is not the behavior we want. So we need something stronger than that. But as far as the actual mechanism goes, it's similar. It's very similar architecturally to the global token verification.
It reminds me a little bit of SIBA, where we have a organization initiating an event. And so in this case, the organization is initiating an event to revoke the token instead of authenticate the user. But it reminded me a little bit of SIBA in that way.
Yeah, I could see that. I could see that. One of the other things that has some overlap with this idea is the shared signals framework. So the idea of passing signals around about risk events, right? Like this is, you can connect these two systems and they can share messages about things that happen. And one of the things that can happen is a user changes their password. So there might be an event saying password changed, or there might be an event saying user anomalous behavior detected for this user, right? Those might be events that are passed around using the shared signals framework. The reason that that doesn't work for this purpose is that those are set up to be signals that are shared, not commands that have a defined outcome. So a transmitter might say, user changed the password. Somebody listening for that event would say, oh, the user changed the password. So yeah, I will log them out of this system because their password changed. But there's no requirement that somebody does that on a password change event. It's more about just sharing the fact that the password change happened, right? So again, we need something stronger than that, which is, no, really, like I'm telling you, revoke this user's tokens. There is no ambiguity here. So
Let me actually show I'm sorry, did you have more?
yeah. No, go ahead.
I'm going to actually show a request, just to somewhat instructive to me sometimes to just look at what a sample, a non-normative sample request.
Mhm.
And actually, you talk about, or several in the spec. I like this one a lot,
Mhm.
because it says, here's the issuer, here's the subject. Let's revoke this one. Note there's actually, in this example, there's a access token presented because this global token revocation endpoint will almost certainly want to be protected, although maybe
Yeah.
not. But maybe I guess let's start there.
Yeah.
First of all,
So,
why not define a standard scope um, for protecting this thing?
well, let me back up a second. So, yeah, what you're looking at here is sub ID is the field where the user identifier gets passed from whatever the tool this is to the token verification endpoint, and that sub ID can have different formats. The formats are defined in the security event token spec. So this is really just borrowed from that. This particular format makes a lot of sense in many situations because it defines the user by the pair of issuer and subject rather than like an internal user ID that would be from the system. So if this was done through SSO where the user logged into this example.com application with an identity provider, the identity provider is already providing this app with its own user ID for that user. So that'd be the same user ID that gets passed into this call. So that's the sub ID format, which is, or this issuer subject format. And then you mentioned the access token on this request. Yeah, absolutely. This token verification endpoint needs to be protected because if you look at the rest of the payload, it's just, hey, here's a user, go log them out of everything, right? So you only want that to be able to be done by trusted tools. So the way that request is authenticated is not defined in the spec because it's client authentication, so you can use whatever you want. It could be an access token, it could be private key JOT, it could be whatever other things you want to do. So we're not defining that format we're not saying it has to be a bearer token. We're not saying it has to be a certain type of token, but it does say that that request needs to be authenticated. There's what we're actually building is actually a authentication mechanism based on private key JOT that, because these tools are doing SSO already. So if they're already doing ID token validation, checking, a public key for that, we can actually use the same private key to sign an access token JOT that's used in this request. So that's what you'll actually see on the public API docs for the Okta implementation. So okay, to your question about scope though, why not define a scope for this? Was that your question?
Yeah, maybe. I mean, not a must, but maybe like if you're going to call this thing, let's all at least use the same scope to protect it.
I guess I don't see any problem with that, but the reason that didn't, I guess, come up was because I see these as being configured in very tightly coupled ways, where it's not something where you're going to just start randomly clicking around and granting access to give things the ability to revoke your tokens. So if
You know,
if you, I could imagine a scenario in which I go buy a security monitoring tool and I want to plug it into my IDP, my authorization server, and it could provide a button that says like, hey, I need access, grant me access, and then it could request a scope that would then grant the token that it would use in this request, right? I can see that. I think that's probably pretty advanced, and we would eventually get there. But in the meantime, the way this is probably going to work is people are going to copy and paste API keys or use private keys that are where the public key, or else just copy and paste it into the tool, right?
so Skim sort of hand waved over what the
Yeah.
authorization was. And what that resulted is every different vendor provided a different way to protect and different claims. And so I'm just saying, like, a lot of people are probably going to use scopes to protect this thing. Maybe it would be nice to just define, give a suggestion about what that should be, and then
It's
everyone
not,
would
yeah,
probably follow it.
it's not a bad idea to just define a scope if you are going to be using OAuth to issue the access token here. Yeah.
Yeah. And let me add about it. So most of these logout situations, you're thinking about a person, like an account takeover of a person.
Mhm.
But potentially there could be a client, right? Maybe it's not a person that you're worried about, but a piece of software that's using client credential grant to obtain an access token. Um, and maybe we really want to make sure we revoke those tokens. I saw that one of the URI formats in the SEC events, I believe, was a URI format where you could give a URI. Then the question, I guess, is how would you identify a client if it's a client's access tokens that you want to revoke without a person?
Yeah, I hadn't thought of it for that use case, but that makes sense for sure. I guess the rather than a user identifier, the subject is the client application, so it would be the client identifier, right? So you could pass in the client ID.
Yeah. Um, I'll make a quick pitch for this is a spec or a draft
Mm.
proposed by Tobias. And I happen to love this idea because we have a way to reference the OP or the AS, as the issuer, but we have no way to really reference the clients. And so each AS might return a different client ID
Mhm.
for the same client. And so this was always, I thought, missing. Whereas in SAML we have the entity ID, whether it's an IDP or an SP, we have an entity ID. But in OAuth, in a way, there's no entity ID for the client. It's always in
Yeah,
the
I mean,
context of an issuer.
this goes back to the beginnings of OAuth, which was um, it was really about an individual authorization server. Like the assumption is a developer goes and registers for an account and then creates a client at the authorization server. So if you go look at any consumer APIs like the Google API or Twitter or LinkedIn, whatever. You go into their developer console and you go create a client there, and then you get back a client ID and a client secret, right? Um, that kind of just carried over and is the way that things work by default, but there's absolutely no requirement that that's how client registration works. And there are now a number of different versions of clients in OAuth not working that way. Um, and this draft is an example of actually formalizing that. Another place this is actually is true though is in OpenID Federation. If you look at client IDs in OpenID Federation, they're also URLs. And we've also been using URLs as client identifiers in the IndieAuth extension for OAuth as well, because we don't have a client registration step there, because by definition, clients need to work with arbitrary identity providers where there is no pre-established relationship. So that gives us a trust root, essentially, which is DNS for all these identifiers, right? We have a single namespace, which is DNS, that it can be used for client identifiers the same way that the single namespace of DNS is used for authorization server identifiers.
Okay, well, yeah, so it sounds like there's sort of an emerging idea that we should really have entity IDs for clients, but it just not really, fully adopted at the moment.
It's definitely getting to the point where a lot of different communities are coming to the same conclusion, and it's just kind of bubbling to the surface now. It's also a big thing in like the wallet space, where again in the wallet space you don't have pre-established relationships between the players the way that you do in a closed ecosystem of the developer signs up for an account, right?
And where's the token revocation? This sounds like it's also pretty early. Where's that in
Yeah,
the IETF OAuth
same,
working group?
very early days draft right now. So it is it's an individual draft that I've been working on. I presented it I think twice at the meetings, and again next up there is to get the draft adopted by the working group. So hopefully other people agree that this is a useful problem to solve in something close to this way.
Why was this draft so high top of mind for you?
Really just thinking about security and wanting to have a a standardized way to really link an identity provider with all these SaaS apps that are used in an enterprise and tell them lock out this user. Because right now there definitely isn't a standard way to do it, and there's barely non-standard ways to do it. So if you have employees getting terminated, or you have employee accounts getting compromised, you want to respond quickly to that kind of stuff. And we need as many of the applications that an enterprise company uses to participate in that in order to actually get the most secure outcome.
One last obscure question. So CAPE, there's a new authentication OpenID standard, sort of related to security events work also. And I think that there's a CAPE event for account takeover. I can't remember
Mm-hmm.
off the top of my head, but any thoughts about where that fits in with this?
Yeah, so I would imagine. I should have like drawn a diagram of how all this stuff gets laid out, but I would imagine that a tool would publish a so you have an enterprise IDP, and you have a bunch of these SaaS apps that are used by the company, like your docs, your chat, your video conferencing, whatever. And then next to that, you might have this tool that is like monitoring things and doing security monitoring, and that tool would be the thing that might detect an account compromise of some sort. It might be also ingesting those signals from the individual apps. Like your video conferencing app might send a CAPE event to the security monitoring tool, or these kinds of events get shared. That's the whole shared signals concept, right? And then at some point, something makes a decision that says, okay, this user is no longer, we no longer trust that this user is not compromised. So we need to log everything out. So these CAPE signals can be used as the input to that. And at some point, something makes a decision. It could be a person in front of a computer, or it could be an automated process as well. And that decision is then the signal that the IDP sends out to all the SaaS apps saying, okay, this user, go revoke all their tokens. But the point is that the cape and the shared signals are the inputs to that, hints, suggestions, signals, where once you add them all up, you can say, okay, yes, we need to actually log this user out now.
Okay, did I miss anything? We're right at the end. Should go to my
Yeah,
final
no, that's
screen.
great. I guess the my call to action here would be, if this is an interesting problem to you, please get in touch with me, let me know, and also feel free to just chime in on the OAuth mailing list and say, hey, I like this global token revocation thing. So yeah.
Okay, thank you so much, Aaron, for joining us.
Great, thanks for having me.
And the next episode, we have Offer Friedman and David Motti, and we're going to talk about some of the challenges around deep fakes. The AI has gotten so good at generating people for especially server-side facial recognition. It's creating some real challenges, and we're going to have a discussion basically about deep fakes. How can we stop fraud in this new with these new challenges? So please join us next week. It's at a weird time, so check the schedule. And Aaron, thanks again, and audience, thank you so much for joining us, and we'll see you next Tuesday.